for joining me on Fascinating Frontiers, episode 84. Today is May 29th, 2026. Here's what's happening in space and science today. A lost ice giant may explain how Jupiter and Uranus acquired their moons. New research points to a vanished third ice giant that once orbited between Jupiter and Uranus. Its gravitational influence could have scattered material that later coalesced into the moons we see today. The study draws on orbital simulations comparing current moon systems with scenarios that include an extra giant planet. Evidence comes from the similar compositions and orbital patterns of several irregular satellites around both worlds. The work suggests this lost body was ejected early in solar system history. Follow-up dynamical models will test whether the same event also shaped the Kuiper belt. Now shifting to a modern technique that weighs planets still forming today. Researchers at the University of Warwick developed a method to weigh forming planets by measuring gaps they carve in surrounding dust disks. The technique uses high-resolution images from ALMA to map how dust is cleared at specific orbital distances. Gap width and depth correlate directly with the planet's mass through hydrodynamic models. The approach works on systems still embedded in their natal gas, offering a window into the first few million years of planet growth. It avoids the need for direct imaging of the planets themselves. Next steps involve applying the method to a larger sample of disks observed by ALMA and JWST. From measuring planets in formation to instruments designed to map the distant universe in bulk. A new facility under construction in western China will obtain spectra for thousands of galaxies each night. The instrument combines a wide-field telescope with thousands of optical fibers feeding individual spectrographs. It addresses the current imbalance where billions of images exist, but spectra remain scarce. The design targets faint objects across large sky areas to measure redshifts, compositions, and velocities in one pass. Once operational, it will map cosmic structure on scales previously limited by spectroscopic coverage. Data releases are expected to begin within 2 years of first light. From gathering vast new datasets to protecting the hardware that will carry those data on deep space missions. A new memory technology uses ferroelectric materials that retain data without power and resist radiation damage. Laboratory tests expose the chips to radiation doses equivalent to 100 million X-rays with no loss of stored information. Conventional flash memory fails at far lower levels, limiting deep space missions. The chips could store science data on probes traveling to Jupiter or beyond without heavy shielding. The design exploits the spontaneous electric polarization in certain crystals that remain stable under particle bombardment. Flight hardware development is now under discussion with several agencies, from radiation-hardened electronics to another technology that turns precise timing into mass measurements across galaxies. Astronomers at the University of Alabama in Huntsville used 54 millisecond pulsars as precise clocks to detect gravitational perturbations. Tiny timing shifts revealed the mass of the Large Magellanic Cloud and the Sagittarius Dwarf Galaxy, including their dark matter halos. The method measures the galaxy's gravitational pull as they orbit the Milky Way. It provides direct mass estimates without relying on visible stars or gas alone. The same network of pulsars could eventually map the Milky Way's dark matter distribution. Additional observations will refine the measurements and extend the technique to more distant satellites. You know what's fascinating about this? If the sun were compressed into a sphere the size of Manhattan, a single teaspoon of its material would weigh about 1 billion tons. Millisecond pulsars are neutron stars spinning hundreds of times per second, sending out radio beams that sweep past Earth like lighthouse flashes. When a passing galaxy tugs on the Milky Way, the distance between us and the pulsar changes by mere meters, enough to advance or delay the pulse arrival by microseconds. A network of 54 such clocks spread across the sky can isolate these minute shifts from the galaxy's overall motion. The surprising result is that the mass of the Large Magellanic Cloud, including its dark matter halo, can be read directly from the timing residuals without ever seeing the dark matter itself. The remaining mystery is why the measured masses sometimes differ from those inferred from stellar motions alone. from weighing galaxies to a deeper look at how the same pulsar clocks actually work. A New Glenn rocket exploded during a ground test on the launch pad in Florida. The blast could affect Blue Origin's timeline for delivering the Blue Moon lander under NASA's Artemis program. Without major modifications, Falcon Heavy cannot serve as a substitute launcher for the mission. NASA is now assessing whether the setback delays crewed lunar landings. Engineers are reviewing video of the fireball to determine the failure's root cause. A revised schedule is expected after the investigation concludes. From commercial setbacks to steady robotic progress on another world, mineral layers mapped by Curiosity in Gale Crater show a transition from wet to drier conditions over time. The rover's instruments detected clays formed in water-rich environments overlain by sulfate-rich rocks that formed as water became scarce. The sequence provides a timeline for when Mars lost its surface water. Orbital data from Mars Reconnaissance Orbiter helped place the rover observations in broader context. Scientists are now correlating these layers with climate models of the planet's early atmosphere. Future samples returned by Perseverance will allow laboratory confirmation of the mineral ages, from Mars climate history to evidence that some stars are still consuming their planets. A study in monthly notices of the Royal Astronomical Society presents chemical evidence that young red dwarfs ingest nearby planets. Spectra of the stars show elevated levels of rock-forming elements that match the composition of terrestrial worlds. The pattern appears strongest in systems still surrounded by debris disks. The findings support models in which inward migration brings planets close enough to be accreted. Observations from several ground-based telescopes contributed to the sample of 20 stars. Additional surveys will determine how common this process is among low-mass stars. SpaceX will fly the Starlink 10-53 mission from Cape Canaveral Pad 40 at 8:57 a.m. Eastern Daylight Time. The Falcon 9 first stage will attempt a landing on a drone ship after delivering the satellites to low Earth orbit. This marks the 49th Starlink dedicated launch of 2026. The satellites will join the growing constellation providing global broadband coverage. Weather and range constraints will determine whether the launch proceeds on the first attempt. Live coverage begins 1 hour before liftoff. The Batagayka crater in Siberia appears in a new Copernicus Sentinel-2 image as a steep-walled depression formed by thawing permafrost. The feature, known as a megaslump, continues to grow as melting exposes fresh ice-rich ground. Radar and optical data track its expansion rate over multiple seasons. The crater offers a visible record of how warming temperatures affect Arctic landscapes. ESA plans continued monitoring to quantify sediment and carbon release. Sentinel-1 radar observations of South Africa's Maize Triangle reveal how different crops change through the growing season. The false color composite distinguishes maize, wheat, and other fields by their radar backscatter signatures. Seasonal changes in plant height and moisture produce distinct temporal patterns. The data cover the southern hemisphere summer when optical satellites often face cloud cover. Agricultural agencies use the maps to estimate yields and plan harvests. A bright meteor was recorded by a Fievel's camera at 10:33 p.m. local time on May 25th. The streak appeared above the volcano and lasted several seconds before fading. No fragments have been recovered so far. The event was unrelated to volcanic activity. Similar meteors are common, but rarely captured at this resolution. Venus and Jupiter dominate the western sky after sunset through early June. The summer triangle rises in the east as twilight fades. The Milky Way becomes visible once the moon sets later in the week. Observers can follow the planet's changing separation each evening. Binoculars reveal the Pleiades near Venus. The full moon on May 31st qualifies as a blue moon because it is the second full moon in a calendar month. It rises in the constellation Ophiuchus. Observers in the Americas will see it low in the southeast at sunset. The moon will appear slightly orange near the horizon due to atmospheric scattering. No special equipment is needed beyond clear skies. The next blue moon occurs in 2028. The fourth magnitude star, Nu Draconis, in the head of Draco, separates into two nearly identical components with small binoculars. The pair lies 100 light-years away and shares common proper motion. Both stars are slightly cooler than the Sun. The double is a classic test for steady atmospheric conditions. It remains visible through summer evenings. Keep an eye on follow-up observations from the Pulsar Timing Network as more data refine the dark matter maps. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly through